Hello everyone, I am Ashin. Today I am going to discuss how a DC power supply draws current from a load. How to perform charging and discharging tests for multiple batteries at once. In the end, we'll discuss the smart power grid topic. It is the same topic as the energy management system I mentioned in the last episode. Let's discuss the DC power supply first. People often think a power supply unit, PSU, provides power to the load. Thus, the PSU acts as a current source. Can a power supply unit, or PSU, draw current from its connected load? Yes, it can, but only for specific PSU units. This is known as a bidirectional power supply. When it supplies power to the load, it outputs current. When the PSU consumes power, it draws current from the load. Now let's consider the case with positive voltage. Most comprehend that power supply units typically output current. But in terms of drawing current from the load, it isn't easy to comprehend. In a broad sense, it is generally understood that a PSU consistently provides current output. But presently PSU draw current. Therefore, it is not easy to fully grasp the entire comprehensive picture. Let's consider an example. When testing an electric vehicle motor, the power supply unit, or PSU, outputs current for the vehicle's movement. However, when the vehicle moves downhill, it appears the motor is driven by the vehicle. At this point, the motor begins to act as a generator. Thus, the motor outputs current to the power supply unit, which is reversing the current direction. The bidirectional PSU is capable of absorbing the current at this point. If the test scenario closely resembles that of an electric vehicle motor, we can use a bidirectional PSU to conduct the test. Since a bidirectional PSU can draw the current, you might possibly start to think, the part of the current output should be a DC power supply. The part of the current input should be an electrical load. You can imagine that scenario, but it's not implemented that way. Because it employs the identical circuit to manage direction of electrical current flow. How to determine the current direction? It depends on the external voltage. If voltage is below PSU setting, the current direction is outward. This is a general use case. Assume you set 5 volts. Suppose you have an external USB disk drive. A disk drive doesn't generate voltage, so it's 0 volts. 5 volts is greater. Thus the current direction is outward. If the voltage exceeds the PSU setting, the direction of the current is inward. Suppose you set it to 5 volts as well, and the external device is a 7.4 volts lithium battery. The voltage of 5 volts is lower than that of 7.4 volts. Hence, the current direction is inward. It seems easy to understand. If you truly think deeply, it seems something strange there. Since the voltage differs between the PSU setting and the external device. This is high, that is low. What about the voltage between the two sides? I mean at the connection point. Is the voltage of it following the high voltage side, or does it instead follow the low voltage side? This is indeed a significantly important question. Normally, the connection point typically follows higher voltage side, as long as the PSU current capacity is large enough to cover the load consumption. The voltage at the connection point essentially keeps the PSU setting as previous. If the load draws too much current beyond the PSU capacity, the voltage at the connection point drops. Finally, voltage is balanced between sides. To understand this, imagine there is a resistance in a PSU. Higher current increases voltage drop due to resistance. This method simplifies understanding. What does a bidirectional PSU look like? Let's examine this. This is the Texio bidirectional PSU PBW. GW Instec also carries this product. I am simply displaying the photo here for everyone to see. Its maximum output voltage is up to 525 volts. In certain models, the voltage reaches 1000 volts. One instrument can conduct 400 volts or 800 volts EV tests. This particular instrument, for reasons, will not make an appearance on my desk. Because it is an instrument with 1000 volts capacity. Its power input is 3-phase 3-wire 220V. People generally don't have 3-phase power at home. A typical house in Taiwan uses single-phase, 3-wire 110V. If a device requires a 3-phase electrical power source, it is probably designed for substantial power loads. This is because 3-phase power can provide a consistently stable output of power. Therefore, its primary use is for conducting motor-related tests. particularly in the power industry. The main application is in the electric vehicle sector. Did you fully comprehend what I just said to you? Let me repeat the name once again: regenerative bidirectional power supply. You may notice the term, regenerative, appearing before the name of the instrument. What does it mean? It means the current can be efficiently reused and recycled during the test process. It conserves power. But how does it work? Firstly, let's discuss how people waste power. I mentioned that the current power returns directly to the source while a vehicle is moving downhill. The current amount is usually huge. The amount may be hundreds of amperes. When we start the test and check the current energy output we're observing is approximately the same as if 20 electric thermoses were all boiling water at the exact same time. When the huge current returns to the power source, the incoming electric power converts into heat energy if this bidirectional PSU absorber is a resistor structure. Every test you conduct consumes electrical power. Essentially, this is a one-way ticket for this conversion. If the test runs numerous times, your lab's temperature rises. You might use an air conditioner to cool down. Thus, you need additional funds to pay for it. In this case, a regenerative PSU is needed. This system allows redirecting the electrical current into the power grid, not producing excess heat. Therefore, you can conserve most power during the testing process. Of course, the instrument consumes some power, but most power returned to the power grid. So the regenerative bidirectional power supply technology can help us use energy more efficiently. For PBW, this device is a highly efficient, regenerative bidirectional power supply system. The system retrieves the current energy and applies it directly to the existing power grid. Regarding its application, let's talk about the DC-DC converter. Every electric vehicle has this converter. It transfers energy from the high voltage of the battery to low voltage for general use. The battery must undergo the process of charging and then discharging. The DC-DC converter must be bidirectional. To test the converter, it is imperative we alternate the flow of current between the two opposing sides. Thus the connection is: there are two PBWs on each side of the converter. These two PBW specs differ due to varying voltage and current on each side. Generally speaking, one transmits, the other one gets it, and vice versa. Regardless of current direction, most current returns to the power grid during the test period. It saves energy. Of course, some power consumed by the instrument. The current essentially travels from one side to the other. This method is cost-effective. Otherwise, you're squandering your hard-earned money. Therefore, PBW is suitable for electric vehicle test scenarios. For battery or power-related tests, you may be aware that the test method involves either sending or retrieving current to or from the load. We can say that this particular test is straightforward and remarkably simple. Generally, there's no problem if we operate only one test environment manually, because one person handles one thing at a time. Attempting multiple things at once can make you lost. Testing multiple devices isn't easy. The complexity increases significantly. To maintain the test, you must check each DUT constantly. This means it's better to use a program for the purpose of automatic testing. Now you might have a question. Do you write the program yourself or have someone else do it? It depends on what you need, to save money or to save time. This is a typical resource allocation issue. If you need to save time, you must pay for an instrument. This is the IoT Wizard from GW Instech. The system supports various instruments and battery test items for most global manufacturers. All options are listed in the menu. Power supply, electric load and internal resistance meter. All you need to do is select the corresponding instrument model and the test item. This machine handles all test items for you. It supports all instrument commands such as SCPI. They are all implemented. In the last episode, one mentioned an advanced battery charging and discharging test system. Actually, there is an IoT Wizard in the system. That's why we have many different combinations for various test items. Once the IoT Wizard is installed with the instrument, it becomes a test station immediately, even more stations, because it can control up to 16 instruments at the same time. so you can monitor simultaneously for different devices such as load or power supply. Okay, let's imagine that IoT Wizard is some kind of data collection center. It enables you to get the status from each instrument through a network anytime. IoT Wizard automatically collects data from various front-end sensors. So this is the concept of the Internet of Things. It accesses the Internet via Wi-Fi. Essentially, you can constantly monitor the status of each instrument anytime, anywhere. Additionally, it has an AR function. It can blend virtual content with real instruments on the screen. If you use an iPad to inspect each piece of equipment, the screen would look like this. I took this video at an exhibition several months ago. This is exactly what I saw. It was pretty cool. Regarding the Wi-Fi connection we mentioned, Wi-Fi is a type of short-range wireless technology. If the application field is a shore or forest, the scenario will be different. Let's discuss offshore turbines. How do we obtain real-time measurement data from the turbine? Distance is long. 4G LTE is key for long-distance access. LTE is a long-range wireless technology. Imagine each energy device reporting status independently. What would the world look like then? I believe energy could flow among devices more efficiently then. This is a type of energy management system. In fact, this is a smart power grid. Historically, power dispatch has been operated area by area, with sufficient energy information. A smart grid can dispatch power in more detail. For instance, an electric vehicle can assist during home power shortages. In relation to wind turbines and solar power, their energy can be incorporated into the main grid based on the generator's power status. In fact, the smart power grid is not new. As time progresses and technology advances, especially in wireless technology field, its pace is swift. It allows us to witness the implementation of the smart power grid. In reference to the IoT Wizard, it can serve as a front-end sensor node in this power grid. It is like an acquisition node. About the back-end integrated scheduling system. It necessitates individuals from diverse fields to construct it. Today, I've briefly shared some insights, such as the regenerative bidirectional power supply, and the method to obtain the status of front-end sensors via IoT Wizard. We can even envisage it as a crucial front-end node of an advanced smart power grid. Its concept aligns with IoT. That's all for today. I hope all gain something valuable. Don't forget to subscribe to StrongPy Lab. Goodbye for now.